So what we're looking to do on this problem is to recognize that there's basically 4 different intervals, and our job is to find the rate of change over these intervals and then compare them and analyze and decide which one's the biggest. So essentially this is giving you an x1 and an x2 down here in the multiple choice options and 4 different problems to work with. Our job is to find the coordinates that go with them, find their slope, and decide which one's the biggest slope. So the nice thing is it's a table, so the outputs are right there. This goes 0, 36. You see that right here up at the table. And then we have 3, 363. So that first interval from 0 to 3 is asking you to find the slope between those two. So we do it and get 363 minus 36 divided by 3 minus 0. So our job is to actually divide that, to work that out, to divide that. And so you go ahead and throw that in your calculator. So the calculator spits out 109. And that's just one of 3 that we get to do. So now let's do the next one. This is 3 to 14, so 3 goes with 363, so it's really 3, 363. And the second coordinate's 14, 571. And our job is to just find the slope between those. So then you take your calculator and do 571 minus 363, all divided by 14 minus 3. Now that's going to give us a decimal of 18.9. It doesn't matter that it's a decimal. What matters is that that is dramatically smaller than 109. So now we keep going because we're fishing for the biggest one. Right now 109 is a big candidate. So now we try the next one. We got 14. 14 goes with 571, 33, which goes with 887. So we take those coordinates off to the side and work it. So it's 887 minus 571 over 33 minus 14. And then we throw that in our calculator. We're going to get another decimal, 16.6. And 16.6 is still nowhere near 109. So that is not my answer. Still 109 is the winning candidate. I just have one more check to do. And yes, you have to check them all. 33 goes with 887. And then 62 goes with 1388. So we find slope with that one. So 1388 minus 887 divided by 62 minus 33. So you throw that in your calculator, you get another decimal of 17.2 and realize that all that extra work was sadly for nothing because your first answer was the right answer. No, it doesn't work like that every time. We got lucky this time that it was first, but that is how we do it. We have to try each interval, analyze, and see which one gives us the greatest value. So this is how you do it if you have a table. And then on the next example, we're going to see how to do it if you're given a graph. When we're given a graph, it's all visual. And so it says which interval of x is the average rate of change of the function the smallest. Now, my assumption would be that the intervals that they're going to give us are going to be basically from this coordinate to this one, and then this one to this one, and then this one to this one. That's what naturally flows out of there, right? But what could happen is they could say, well, let's go from 0 to the end. So this could be one interval, and basically you would get a line that goes from here to here. And then they could do another interval from, say, this coordinate to the end. And then you would analyze the coordinate from here to the end, and you'd see which one's which one's the less steep slope. So visually, you can do it pretty quickly, but thankfully, this problem is actually very convenient. Like I showed the first part, it's just little segment by little segment. So you can see right away, this is the steepest. Steepest would be the greatest rate of change. And that's the idea here. We're visually trying to see which one's the smallest. So as you go along, you can say this is right here. My eyes can see that is the least steep, which means its rate of change is the smallest rate of change. Now, as I said, the intervals that we're being asked about are, it says from 0 to 2, and that's the steepest. And then our next option is from 2 to 6, and then that is the answer. That is the least steep. And then 6 to 10, you see it's steeper. And then the only close candidate is this one right here. But if you kind of just stare at it, right, you can see that this is, if you took that slope here and just kind of pieced it over here, it's kind of feeling like that. You could actually count the rise and the run if you really wanted to compare it, but you're definitely the least steep right here on this interval. Hopefully you can see that. If you can't see it on any given problem, you actually should count the rise, which in this case would be 2, and the run is 4. And so we'd say 2 over 4 is the rise over the run. And then in this case, they tell us that that height is 9. So we're going 9 to 16, which is a rise of 7. And the run is going 11. So 7 over 11 is bigger than 1/2. So we know that this would be the smallest slope. I said 1/2 because 2/4 reduces to 1/2, of course.